All students of class 10. Today I take a class of class 10, chapter work, energy and power. At first we read what is work. We have already know that what is work. W-O-R-K, work. In practical language, in our daily life, where all students read in class, read, writing and eating, etc. These are all we say that this is work. This is said to work. What is work? In Finnish language, work is said to be done when a object displaces under a influence of force. If force is acted on a body but there is no displacement, in Finnish language this is not work, is not to be done. So we define work. Work is said to be done only when a force applied on a body and the body moves around the direction of force. Example, we try to understand. We give many examples of work. When a cyclist pedals cycle and a student or a boy can try to carrying a load, a coolie carrying a load or lifted a load, etc. This is in our practical language. We are say this is work. But however, in such a situation, when a man try to push a wall, or a student or a child tries to push a stone, but they cannot successful. In Finnish language, in this situation, no work is to be done. This is the concept of work we described already. We have already known. Next, measurement of work. Measurement of work. How we can measure work? Actually, Work is depends on, in our previous discussion we can see that work is depend on mainly on amount or magnitude of force. Second, the displacement of a body by force. Measurement of work is the product of the magnitude of force and the displacement of a body by the force. Mathematically we can write W equal to, work is denoted as W equal to force into displacement of a body. Displacement of a body. That is W equal to F into S. This is the mathematical terms of work. W equal to F into S. Here F magnitude of force and S is denoted as displacement. So we can prove that W equal to F into S. Next, expression of work. Expression of work. W equal to Fs cos theta. W equal to Fs cos theta. We face such a situation when work applied on a body, but body moves other than the direction of force. In this case, we calculate of work. Actually আমি যেটা বলতে চাইলাম সেটা হচ্ছে আমরা ফোর্স অ্যাপ্লাই করেছি একটা বডির ওপর, কিন্তু কি হয়েছে বডিটি ফোর্সের ডিরেকশানে মুভমেন্ট না হয়ে ডিসপ্লেসেস না হয়ে অন্য একটা ডিরেকশানে একটা অ্যাঙ্গেল করে ডিসপ্লেসেস হয়েছে। এই সিচুয়েশনে আমরা কিভাবে ওয়ার্ক ক্যালকুলেট করব? চলো দেখা যাক। তো we consider a body, a force, angle theta. This is the direction of force. This is a body. This displacement AC, here AC equal to S. This is the actual displacement. এখন যে কন্ডিশন নিয়ে আমরা আলোচনা করছি, we consider a situation when a force applied on a body, but body displaces a direction other than the direction of force. That means the body displaces A to C, but if it is force applied the direction according to along to AB. Theta is the angle between displacement and the direction of displacement of a body and the direction of force. Actually, from ABC, from a triangle A, B, C, here we can see ABC is a right angle triangle. Angle B is 90 degree. We calculate the value of cos theta. Here cos theta equal to base and hypotenuse. All students already know that cos theta equal to base by height, base by hypotenuse. Here base AB and hypotenuse AC. So AB equal to AC cos theta. Here AC means S. Already we can consider, we can write S equal to S cos theta. That means the component of displacement equal to AB cos theta. AB is AC cos theta. Here AC equal to S cos theta. We calculate the value, the component of displacement. We already calculated the component of displacement along force AB equal to S cos theta. There are two ways to calculate the expression of work in this situation, in this condition, where a force applied on a body, but body displaces a direction other than the direction of force. This is a component of displacement AB We already calculated AB equal to S cos theta. We already learned that work equal to F into AB. That means S cos theta. That is W equal to Fs cos theta. We can already prove W equal to Fs cos theta. Another situation, calculating a component of a force along the displacement. আমরা দেখবো সে আগের ছবিটাই, আগের পিকচারটাই দেখবো। AC is an inclined plane. This is a body. F applied along direction of AB. We can project of displacement along AN. Here we can draw a perpendicular FN. Here theta between direction of force and the position of displacement. This is called theta. Here work W equal to here AC is equal to F equal to magnitude of force. Sorry, AC no AM equal to F magnitude of force. We can write W into F into S. That means AM into SAM. Here AM equal to F into AN. Now we calculate the position of displacement AN along the displacement and the direction of displacement. We can understand that MAN is a right angle triangle. From right angle triangle MAN, we can write cos theta equal to base by hypo. That is here base here base an and hypo am. We can already consider am equal to f an by f. And n equal to component of s, that is, or an equal to f cos theta. Here we calculated the component of displacement along the direction of force. N equal to f cos theta. This value we can put in equation 1. We can write W equal to f into n, m equal to, here m means AC. That means AC equal to s, n equal to s cos theta. W equal to f into AC, f into s cos theta. W equal to here n, total distance AC, displacement. Then we can write work equal to f s cos theta. Another situation when by finding the component of force along the displacement. The expression we already calculated, W equal to f s cos theta. Here work is depend on magnitude of force and the displacement s, and the angle between the displacement and the direction of force. Some special case. Number 1, when theta equal to 0 degree, that means a force applied or acted on a body, the body displaces in the direction of force. That means theta equal to 0. Here cos theta equal to cos theta equal to 0. So cos 0 value on, cos 0 equal to 1. You can write W equal to Fs. Situation 2, when theta equal to 90 degree. In this situation, cos 90 equal to 0, W equal to 0. No work is to be done. When the direction, the angle between the direction of force and the displacement equal to 90 degree. That is, when a pulley moves along a horizontal displacement, horizontal road, and he carrying a load on his head. In this situation, the direction of his movement, that is direction of displacement, and the force of load acted downward, and angle in this situation equal to 90 degree. That is perpendicular created. In this situation, in physics language, cooling, no work is to be done in this situation. Condition no work. Condition for no work is to be done. First condition, when there is no displacement, that is h equal to 0, and when the displacement is normal to the direction of force, that is theta equal to 90 degree. In these two situations, no work is to be done. We consider a free falling body, that is a body moves downward from a height h. In this situation, the force equal to gravity. The force acted on a body by gravity. Here F equal to mg, and here S displacement h, W equal to F into S. Here F mg and displacement h. We can prove W equal to mgh. Here work done is equal to mass into gravity into height. Next, unit of work. First, SI unit. We can write from expression W equal to F into S. That means SI unit of, we have already read that SI unit of force Newton, and SI unit of displacement meter. Newton into meter is called joule. That means 1 joule equal to 1 Newton into 1 meter. When a force, 1 joule is defined as when a force applied on a body, when a force, 1 Newton force applied on a body, and the body displaces 1 meter. This force is called equal to 1 joule. Next to CGS unit. CGS unit of work W equal to F into S. CGS unit of F equal to dyne into semi. Dyne into semi is called arc. On arc equal to on dyne into on semi. On arc is defined as when a on dyne force applied on a body and a body displaces on semi. This is equal to on arc. Relationship between on joule and arc. Now we can find relationship between Newton and dyne. Newton and SI unit of work. SI unit of work joule and arc. We have already known that 1 joule equal to 1 Newton into 1 meter. But 1 Newton here, 1 Newton into 10 to the 5 dyne and 1 meter equal to 10 to the power 2 semi. This value is put in equation 1. 1 joule equal to 10 to the 5 dyne into 10 to the power 2 semi. That means 10 to the power 7 dyne into semi. Dyne into semi is also called arc 10 to the 7 arc. This is the actual relation between joule and arc, SI unit of work and CGS unit of work. Next, we learn energy. What is energy? We have already read in class 6, 7, 8. What is energy? What is the concept of energy? Energy is defined as capability or capacity to do work. অর্থাৎ কাজ করার ক্ষমতা, তাকে আমরা এনার্জি বলছি। Unit of energy. Unit of energy. On joule. Arc. Third, calorie. Fourth, EV, electron volt, etc. Here we can learn unit of energy, SI unit of energy joule, CS unit of energy arc, and another unit of energy calorie. Calorie is used is particularly used for determining the temperature. Electron volt. This is a smaller unit of energy. Electron volt is used for calculate smaller energy for atom. Next, power. We have already known in class 7 or 6 or 8 what is power. Power is actually defined as work done per unit time. That means rate of work done. Rate of work done is called power. Power is defined as rate of work done. That means mathematical expression power P equal to W by T. Unit of power P equal to SI. At first you calculate SI unit. P equal to W by T. SI unit of work. SI unit of work we already learned. SI unit of work joule. Second, SI unit of time. Second, that means joule per second. Joule per second is also called watt. CGS unit of power P equal to CGS unit of work we already learned R per second. R per second. Actually, power is depends on amount of work done and the time taking for this work done. Relation between SI unit of power and CGS unit of power. That means relation between SI unit of power, SI and CGS unit. On joule per second, ten to the power 7 R per second. This is the relation between SI unit of power and CGS unit of power. This is the actual part of your chapter work, energy and power. We already discuss about work, energy and power. We can also know difference between power and energy and work and power. তো আজকে এই পর্যন্তই। নেক্সট চ্যাপ্টার নিয়ে আমরা পড়া শুরু করব। ততদিনে তোমরা ভালো করে শুনবে, কোনো ডাউট থাকলে আমাকে বলবে। ওকে।